Hi, everyone. Just wanted to take a minute to talk a little bit about finding the area of composite figures. So, just to clarify and make sure we're on the same page, a composite figure is really just going to be a kind of a figure that looks like one of these over here, or any other thing, that can be divided into one or more kind of basic shapes. And by basic shapes, we're really talking about things like, circles, rectangles, parallelograms, trapezoids, triangles, anything you kind of have a direct formula to be able to find the area of, um, just because those are easier to work with, right? If we know we have a trapezoid, we know how to find that area. And if we know we have a circle, we know how to find that area. So that's ultimately our goal. We're going to be using kind of different shapes added or subtracted from each other to find areas. And there's kind of like three almost, I don't want to say there's three main categories, but there's kind of some different types that you can encounter. So, for example, this first one, um, you kind of have a shape that looks odd, but in all actuality, it's really just that this part right here has just moved over here. So this is this is actually just a rectangle with the part moved, right? So that's kind of misleading. It looks kind of almost composite E, um, but it's really just a rectangle in disguise, so to speak, when you start moving things around. So to find the area of something like this, you would end up actually just doing um, base times height or length times width. So it'd be 14 uh, times 4, which is 56 units squared. Unit, there it is. All right. Alternatively, let's say you didn't realize that this looked like this, and you could kind of make it into a rectangle, so to speak. Well, what could you do? Well, this obviously, right here, this is a semicircle. So you can find the area of that, right? You can find the area of just this part, which would be pi r squared over 2, because it's only half the circle. You can then find the area of this rectangle and subtract this semicircle, which you can very clearly see is just then going to ultimately result in you getting the rectangle again. Um, but don't forget, you can subtract as needed, right? So you could do the 14 times 4, which is 56, minus, this is a radius of 2. So 4 pi over 2. And then you add in radius squared. Radius is 2. 2 squared is 4 times pi. And it's only a semicircle, so over 2. So, right, these cancel out. And that's how you get that as well. All right. Now, kind of another situation you can encounter is you kind of very clearly can see here that you have a trapezoid and a semicircle. Now, let's say you don't feel like using this as a trapezoid. You can keep going and expand this into two triangles um, and a rectangle and a semicircle. I personally, it doesn't make a difference, whatever works better for you. I'm going to do the trapezoid though. So the trapezoid would be the 1/2, the base, well, the height, I'm sorry, the height, which is 4, times base 1 plus base 2, which is 7. And I'm going to add in the area of that semicircle. Now, we have a radius of 1 pi, because 1 squared, and it's only a half, so plus 1/2. Now, when we find the area of the trapezoid, we have 1/2 times 4, which is 2, 2 times 7, which is 14. So we have 14 plus pi over 2 units squared. And for my purposes, that's fine. If you're on something, an online site, sometimes it'll tell you specifically what to round to. But again, you also could have broken it into triangles and used the triangles and gotten the same result. And finally, you have a parallelogram, or alternatively, once again, you can kind of try and break this up into other shapes. In this case, it's not abundantly clear how much this part right here would be, or if this is necessarily, let's say this is 8. So you could probably do the math out and make that work. But I think this is probably easier to break into a parallelogram and a semicircle. So if you do the parallelogram and semicircle, you'd have 12 times 6. 12 times 6 would be the, ooh, where'd it go? 72. And again, this right here is the same as here because this is a parallelogram. So this has a diameter of 8, so it has a radius of 4. We have 4 times 4, which is 16 pi over 2. So we have 72 plus 8 pi units squared. And there you go. So alternatively, there's plenty of other shapes that you can come up with. Just you want to try and break them into things that you know how to use and into values that are, definitely feasible to work with, right? So as I was talking about, you probably could try and break this up, but it might not be abundantly clear. Um, how to separate this if you try drawing that line there, right? If when we have the parallelogram, it's clear that we know this is 8 and this is 8. If we draw this in, we might have to, try and use some of the information we know about, well, really the parallelogram, to figure that one out. But whatever way works is up to you. Just try and make sure you don't overcomplicate it. All right, let me know if you have any questions and have a great day.